Okay, welcome back to the DIY Aquarium controller. This is about the relay controlled outlets. I'm just going to hammer through this because it's pretty straightforward. Again, this is about how I did it. Now there are various ways to create relay controlled outlets. So if you were to type into, say, YouTube relay controlled outlet or Arduino relay controlled outlet, there's a whole bunch of different people that have done this in various ways using different outlets, different boxes, different power bars. So you could check out what they did and maybe get some pointers from their videos. But for the purposes of this one, I used this power bar that I bought from Princess Auto. Again, in the States I think it's called Harbor Freight or something similar. They often carry a lot of the same equipment, and probably online in various stores as well. So you need some sort of outlet, mains capable outlet that you can control individually by your relays. You're going to need a relay board. In this case, this one is this build video is about the 8 mechanical relays. If you're getting mechanical relays, I suggest you get them with octocouplers. Most of them these days have octocouplers. A long time ago they didn't, and they didn't last very long, but now that they incorporate octocouplers in their relays, they last much longer than they used to. You're going to need some wire capable of carrying mains voltage. Usually that's a minimum of 18 gauge wire. So I am using some 18 gauge stranded to connect mains voltage to the individual outlets. If you can fit it and use it, 14 gauge is often, more recommended. And then you're going to need some 22-ish gauge wire to connect your GPIO pins to your relay board. You'll also need a 5-volt DC power supply, which comes from your Raspberry Pi, a soldering iron, some solder. An inline fuse holder is greatly suggested with a 10 amp fuse, unless you have a plug that you're plugging in that has a fuse or breaker already in. Like in the UK, they have fantastic plugs with fuses already in them, so those are nice. But if not, you might need to add one to your project here. So these boxes are pretty simple to disassemble. They've just got screws all around on the end caps and then the sides there. So this is kind of what it looks like when the end caps are taken off. Now in this particular box, it's got these 2 rails and a switch, and then the mains in. So the mains in, when it comes in, the green gets split to this kind of connector, and then the green connects to the ground rail on each one, which is about in there. And then the cold wire in North America and Canada, the white is cold, and so that connects to a rail, and the black wire also connects to a rail. Now we're essentially just leaving the cold the way it is, we're leaving the ground the way it is. The only thing we're going to be manipulating is going to be the black hot wire rails. What we need to do, if you see they're all just one big rail in these boxes, what we need to do is we need to separate the rails so they're individual. So that's just a matter of snipping the black rail so they have individual connections. If you see, the rails have these kind of little fold things, so that's where your plug actually pushes in these rails and makes the connection to your equipment. So here we have the snipped black rail. This is where your equipment is plugging in, and then what I did is I just folded over one end, and that's where the wire is going to go in. It sticks in there. I crimp it down and then solder it to your plug rail connection. So here it is actually all together, the rails all together, except for the ground rail, it sits in there. But up here you can see we have the cold rail. That's just still the same. It's connected to the cold wire, and it's just kind of fits in this casing, nice and snug. But the black rail is all snipped. So I've got one down here, I've got one up here, and this is just the 3 side, and it's got one here. So if you see, here's the rail, and then here's the fold, and then what will happen is the soldered wire will be coming in here and then through this hole which I drilled in this kind of like rail holder thing. And here it is put together. So the soldered wires are popping through the holes, and then these wires will connect to the relay that completes the circuit, the hot cold circuit from the mains electricity. The other thing I did is the black wire in, I've got connected to a quick connect here. That's what's going to be connecting to the relay board. If you see over here, I've got the quick connect that's connected to the inline fuse holder. So let's take a look at the circuit. This is just the actual circuit in a diagram form. So consider this like your main power coming in. Now, one thing this circuit doesn't have, unfortunately, I forgot to add it, is a inline fuse holder. So right here, 10 amp fuse would be going right about there in terms of the diagram. Then it comes over here. Also, my wiring color is wrong. This should be, the red should be black wire, and the black wire should be white wire. But so this black wire should come to your first relay, and then it just jumpers to the same position on your other relays. And then the other connection, when the switch is on, goes to the other side of your outlet to complete the circuit. And that's what's controlled by your GPIO pins on the Raspberry Pi. So your GPIO pins, or your pins on your relay, have one for ground, which connects to your Raspberry Pi, one for 5 volt, which connects to your Raspberry Pi, and then these outlet pins that connect to the GPIOs that you designate on your Raspberry Pi to control. This is it's very simple. It's pretty straightforward. There's nothing too fancy. You're not putting resistors or anything. It's all pretty much done. So here we look at the board, kind of the way I did it. So I've got the actual middle rail connecting to my mains electricity, the way it is there, and it just kind of jumpers the same from each one to each one. And the inline fuse holder just kind of comes down underneath, and it runs between these two rail holder things on the power brick. And then here is a 10 amp glass fuse, and it just sits on there, and you see this wire comes down, and the fuse holder actually runs between these two things underneath the relay board and then connects there. And then these wires will come over, and then they connect to the individual relays to complete the circuit. So you got one here, there. So it's pretty straightforward. Here's another view of it to make it a little easier. On this relay board, this is the pinout section. So I don't know if you can see it, but there's the ground there, there's the volts in there, and then there's your numbered controlled things. So you can connect it all that way. And then here's the GPIO wires that I ran. Now they're coming out this end. I could have put them through that actual switch hole that was there, but it didn't look very nice, so I decided just to run them down here and drill a hole in the end cap so they have their own kind of outlet at the same area where the plug is. It's nice and neat, and it works well. And everything fits nice and snug with the lid on. It's not squeezing, so everything fits nice. And then this is what they look like, all connected, all combined. I put a little wire wrap stuff, tubing to keep all the GPIO wires together, and it's nice and solid, and it works. So let's take a look. Once you've done all the hardware and you've created your outlet and your circuit somehow, then you have to connect it to your Reef Pi.